Okay, so I'll come back with chapter 6, and now we're gonna talk about uh, 6.2, the normal model. And in this section, we're gonna find probabilities using normal model, and we're gonna find values for a random variable given a normal probability. Okay. In this session, we're talking about the normal model. Um, it is one of the most widely used probability model for continuous numerical random variables. So remember that in the section 6.1, we talk about discrete numerical and continuous numerical. But in this normal model, we just gonna talk about continuous numerical random variables. All right, so it's also called the bell curve because it's shaped like a bell, right? So let's take a look at a bell curve for next page here. So so we are visualizing the normal model. So as you see in here, this is a normal curve or the or like a bell curve. Um, that's in this curve is showing me about it's showing me a histogram that shows the height for a sample of males, and since it is symmetric and unimodal, it can be modeled using a normal distribution. And in this normal distribution, you should understand that the mean is let me the mean in here is 69, is also equal to the median, and also equal to the mode, and equal to 69. So only for the normal model or normal curve is going to have mean and median and mode at the same value. Okay, so let's move to the next page. So in this page, we have the normal distribution with the same mean, but different standard deviation. Um, so these two normal curve have same mean, which is 0. Okay, so mean is 0. And however, is have different standard deviation. And you have to remember that um, the higher normal curve, uh, um, the higher curve will have or has a smaller standard deviation. Okay, with stand by sigma here, and the smaller or the shorter curve has larger standard. I'm gonna just notate by sigma standard deviation. Okay, so as you see here, in the blue curve here, we have shorter shorter the height, but it's wider, so then it's larger for the standard deviation. Okay, so let's move to the next page. Oh, by the way, want you to note that the area under the curve of both gonna be equal to 1. So under both curve here, for example, this curve, the area under here should be equal to 1. Okay, and For the red one, also the area under the curve here is has to be equal to 1. Okay, so let's move to the next one. Okay, now as you see in here, we have two curves that have the same height, right? Same height. So that's gonna tell me is have a same standard deviation. Okay, why? Because the the spread of each curve in here, they have the same. Okay, they have the same the spread of each curve. Um, so that is the reason why we have the same standard deviation. Okay, um, what about the mean? So for the blue one, the mean, it looked like the mean is about 64. But for the red one, it looked like the mean is 70. So it's different mean because why? Because it have, it have different position. Okay, different position. So different mean. All right. So now I'm gonna move to the next page. Okay. Uh-oh. Okay. So this page talk about the notation. Firstly, you should know that the symbol mu in here that I wrote down in previous page, and mostly we use this mu is represent for the population mean. Population mean. This note is missing this word. We should include it. Okay. Similarly, for the sigma, it should represent the population standard deviation. Okay. And lastly, the notation n parenthesis mu comma sigma is represent the normal distribution with mean is mu and standard deviation is sigma here. So let's say example n is 2 comma 1. Okay, with mean represent normal normal I spelled incorrectly. Normal distribution with mean equal to 2 and standard deviation equal to 1. Okay, so that should be it for this page, and now we're gonna move to the next page. Okay, so next page. Now we talk about fighting poverty with technologies. It is always helpful to sketch a picture of the area you are interested in fighting before using technologies. Okay, so you try to sketch first and use by hand first, or abruptly with some formula first before using technologies. And then most technologies require you to enter the mean and standard deviation of the distribution, as well as the beginning and ending x value of the area you are finding the normal model. Okay, so let's go ahead and try to see if we have an example. Oh, okay. So, uh, okay. So they show us to use TI-84 calculator in here. Um, I would show you to use TI-83 because I don't have the software for TI-84, but it should be similar. So let me open it. Okay, so here is my TI 83. Firstly, you have to push second, and uh, then select option number 2, normal CDF. Second, no, you should put second and then this. So second distribution over here. See the yellow word here, distribution here, which is VARS over here. So click on that. You now gonna appear um, normal PDF and normal CDF. But actually, you mostly will not touch on normal PDF at all. You will work with option number 2, normal CDF. So move down to number 2 here, and then enter. Okay, so now you are trying to find the area um, of under the curve of something. So let's see. Enter the left boundary of the shade area, and then the right boundary of the shade area, and then the mean and the standard deviation, and then press enter. We don't have any problem. Let me see if I miss anything. We don't have any problem that make as an example. Okay, so let's, here is an example. Okay, so yeah, as you can see here, firstly we're gonna enter the left boundary, and then the right, and then the mean and the standard deviation. Okay, so let's move to this one. Okay, so this one is example number 1 is talk about women's height. So it have normal model is has n parentheses 64 comma 3, which mean mean it is normal distribution with the mean is 64 and standard deviation is 3. Do you remember that the mean usually is a big number and the standard deviation should be the smaller number? Okay, so so don't mess up with that. Gives a good approximation of adult women height in inch in the US, and find the probability that a randomly selected adult woman from US is between 62 and 67 inch tall. Okay, so what does that mean? If I draw a normal curve, that middle is 64, right? And standard deviation is 3. So say here from here to here, it should be 67, right? And from no, because it's one standard deviation, I should make it bigger a little bit. Maybe here 67. Okay, and remember that's one standard deviation equal to 3, right? So you have one standard deviation equal to 67, and you subtract one standard deviation, you're gonna get 62. Oh no, 61. Okay, so we want to have the probability that a randomly selected adult woman from US is between 62. So 62 around, say 62 is around here, and 67 is here, right? So if you draw a line under, draw the you want to find the area under the curve from 62 to 67, and try to find the area, find this area. Okay, so then if you estimate it's around, I would say around maybe my drawing is not really well. I should make it less layers because why? Because remember, for the empirical rule, one standard deviation from the mean, it should be like 60 something, 68 some, I think it's 68% or something like that. So this around 60%, I believe, or less or more than that. So that is my approximate. Now let's use calculator to find the answer. So as we have from the previous page, talking about how to use TI-84 or TI-83s to find the area under the curve. You're gonna put firstly, you're gonna put the lower bound. What is the lower bound in here? Lower bound in here is gonna be 62. See that? And the upper bound gonna be 67, right? So put 62 first, 62, and then comma, okay, comma, and then 67, and then comma. Now you put the mean, okay? Don't forget, this step is mean, okay? So mean is 64. And then standard deviation is going to be 3. So then this should be in order to find the area or the probability. So probability that that the height is in between 62 and 67. I mean, I don't need to the equal, but you can equal. It doesn't change anything. So it will be equal to area under the curve here, and now the formula gonna be normal CDF from 60 open 62, comma 67, 60, and then comma 64 and comma 3. All right. So as the formula was normal CDF, a lower bound, and then upper bound, and then mean, and then standard deviation. Okay, so that is the way, and now you're gonna just click on enter. Okay, now you have the answer as 0.588 something. Okay, so I have 0 that have the answer as 0.58. Nah. Okay. So the answer now 0.58. Nah. And I will just circle the answer. Okay. So that is a way to handle this problem. And now we're gonna move to the next page. Okay, so let's see how they did it. All right, so exactly what we did by using calculator. So we use formula as normal CDF, 62, 67, and 64, and 3, right? So the answer should be 0.59. And when you present on the test, you may use this formula as the answer to show with me how you did it, right? That is a way if you use TI-84 or TI-83. Okay, so let's see what is next page. All right. So now we will talk about using StatCrunch. Okay, so research have shown that the distribution of newborn Pacific harbor seals birth length is approximately normal with mean. Okay, so if I see the word with mean here, that means I have mean is 29.5, right? And the standard deviation is 2.5, right? Find the probability that the random select harbor seal prop is longer than 31. It's like longer than. Okay, what does that mean? Okay, so it means you are looking for the probability that X is greater than 31, right? All right, and also in here, in short, I have this should be a normal distribution with mean is 29.5 and standard deviation is 2.5. So if I draw the curve, okay, mean was 29.5. My curve is a little bit terrible, but let me see. Let me try to redo it. Oh my goodness. Okay, hope that's better. All right, so mean is 29.5. Standard deviation is 2.5. So if I move to 1 unit here, it's gonna be if you add 2.5, you're gonna guess 22. If you subtract 2.5, be up to here, then you're gonna get 27. Okay. So what we are looking for is we want to have longer than 31. Okay. So 31 should be somewhere up here. I'm not sure that. Oh, this should be 32. Sorry, 32. So 31 should be around here. Okay, so if I sketch a line for 31 here, and I want to have longer than, so that means the right hand side of 31 area, the right in the right hand side from 31 going to be the probability that we are looking for. Okay, so for this case you can still use TI-83 for this, but okay, so you still have to use the normal CDF, right? Parentheses, first one is lower bound. Lower bound will be 31, okay, because the lowest one is 31 here. And what's the upper bound? The upper bound is keep going, and I'm gonna say positive infinity. But anyway, but in the TI-80 83 or TI-84, we don't have the infinity, so then we assume it's gonna be 999. That should be okay. That should be approximate enough for you to have the upper bound, even though it could be more, like you could have like more 4 letter. That's okay too. But yeah, it just says say 4 number 9, and then what? And then you have the mean. What is the mean in here? 29.5, and then the standard deviation is 2.5. And now let's check it with calculator. So firstly, you click on second, and then distribution, and then number 2. Let me move this one here. Number 2, and now you're gonna put 31, which is the lower bound. You comma 9999, you comma mean, which is 29.5, and then you comma with the mean is 2.5, and close parenthesis, enter. You will guess answer is about 0.274. So this area is actually equal to 0.274, around that. So now let's see how they show you to use StatCrunch for the next page. Okay, let's see. All right, so here we have to use Stat calculator. Let me use StatCrunch. Okay, so now I'm having here is StatCrunch, and firstly you need to click on the Stat, right? Stat, and then calculator. Okay, and then you wanna go to the normal, click on that. Okay, so look like this to me gonna be very easy for you to use. Let me clean up some stuff so you guys gonna use it easily. Okay, so here you can practice it very easily. Firstly, you're gonna put the normal of the mean for this one. It's only 29.5, and then standard deviation is 2.5. For the probability that x is so in here less than or equal to, we had to change it to be greater than 31 right here, right? So change it to be greater than or equal to 31. You should understand that include the equal sign or not include it should not have any different. Because it's normal distribution, so it doesn't matter whether equal or not, with the equal sign, include or not include. Okay, so it's just greater than or equal to 31, then it's just gonna compute. So it show you right away the curve and the area here, and the answer here gonna be 0.274, which is exactly the same as the TI-83 show me, right? So it looks like this one is pretty easy. Come back with the problem with the between. Let me go back to this problem. Okay. Over here, we are looking for the area that that's from 62 to 67. For the mean is 64 and standard deviation is 3. How can we use that range? Let me show you. So mean is 62, right? 64, right? And standard deviation is 3. And then, okay, now we are trying to figure out the area in between 62 and 67. So this one doesn't work. Now you have to click on the button here, which is between. Let's click on between, and now the lower bound gonna be 62, and the upper bound gonna be 67. And then you just click on the compute and everything is in your hand. That should be 0.589 and exactly what we have before. So that is a way to use StatsGrunch for this section. Okay. So here is all the things that they show you, and I did show you already. And without technologies, we will have something like using a standard normal table, or we call it the Z table. However, we don't have to worry about this method with our technologies, because now it's everything changed already, and we are doing online class. So you don't have to worry about this method. And if you still consider how to use how to find normal probability without technologies, you may take a look at the Z table that I post on the discussion board. Let me show you discussion board. Okay, so there is Z and T table here. You consider about it. You can click on it. However, it will make you more confused if you try to use by this way. So I would like to skip this method, and we gonna just focus on using StatCrunch or using TI-83 or TI-84 to handle this problem. Okay, so let's move to the next page. All right. So we did talk about the normal model, right? Now we're gonna talk about standard normal model. What is standard normal model? Is a case or like special case, okay? Special case for the normal. We're gonna give you mean equal to 0 and the standard deviation equal to 1. And actually it's mean that the normal curve in here have the mean equal to 0 and standard deviation equal to 1. So clearly that's called standard normal model. Okay, so let's move to the next one. And now okay, now we have standard units or z-score. This z-score is tell us how many standard deviation from the mean and observation lines. Okay, so let's move to the next page. Oh, actually we have z going to be equal to x minus x bar and over the standard deviation. What does that mean? It should write as x minus the mean, population mean, divided by standard deviation also. Okay. So so now let's see what else do I have. Do we have an example? Okay, good. Here's an example. So we come back with the problem about the seal, right? Again, the mean in here is 29.5. So mean is 29.5. And the standard deviation in here is 1.2. And they say, what is probability that's randomly selected newborn seal is shorter than 28? So we looking for the probability that's is shorter than 28. Shorter should not include the equal, but actually it should be the same answer for the equal, not equal. Okay, so now in this case, what should what you should do now? Okay, if you use StatsCrunch, it should be pretty easy for this one. So let's move to the StatsCrunch. Where's my StatsCrunch? Over here. All right. So you're gonna just click on the stat calculator, and then normal. Okay, the mean in here is gonna be what? 29.5. And then one standard deviation is 1.2. And then what's the question? P is less than 28, right? X less than 28, so 28. And compute, easily you will have answer as 0.1, so 0.11. So I'm gonna have 0.11. Okay, that is or maybe I'm gonna make it more accurate as 0.106. Okay, so that is what we have from the stash branch. So now let's come back with the column here. Um, the thing in here is uh, we try to using without calculator and technologies. I still show you, but you don't have to worry about this problem. I mean, worry about how to use by hand if you do the test. I just need you to use by technologies, but at least you need to know how to do it by hand. Okay, so firstly, the strategy is to uh, you need to convert from the normal curve, the normal distribution. In here is mean is 29.5, and the standard deviation is 1.2. Convert this curve, uh, and here's 28, something like that, right? And I try to convert this curve to be the standard normal curve, that have mean is 0 and standard deviation is 1. So mean is 0 and standard deviation equal to 1. Maybe yeah. One. Okay. And what we need to know is worth 28 here, right? So then from this 28, how to convert it to this z value. So then after that, I will find this area by the z table or the standard normal table to find this area. Okay. So that is strategies. And as you learned from the previous page, that z score will be equal to x minus mean over standard deviation. So x in here was 28, right? You want to convert this 28 to be z. So 28 minus mean was 29.5, and then divided by standard deviation was 1.2. And now you want to have z equal to what is that? Use calculator. You have 28 minus 29.5, and then you divide by 1.2, you're going to get negative 1.25. Okay, so that means what? This z is negative 1 second. Let me just gonna, so negative 1.25. Okay, so if you see is why it's become negative here, because you see that it's below 0, so it should be negative, right? So it's so just Just roughly estimate, and it should be it look okay to me. Okay, so now we did have z equal to negative 1.25. So I need to go back to the z table to find the area that under the curve from negative 1.25 to the left, which is the area here, the red one. So let's go to the table. Okay, a little bit small, but if you make it bigger here. Okay, now because this talk about um, the z value, the standard number cumulative probabilities, and because it is a negative, we have negative 1.25. So you look at the first one, is the first column here is the z value here. You will look at the negative z value, which is the left page here. So we are looking for the z equal to negative 1.25. So you look for negative 1.2 first. So here is negative 1.2. Okay. So we are having 1.2 already. But where's the 5? In order to have negative 1.25, the second digit is going to be using the first row. Okay, so the second digit is 5 here, right? So you will use this column for the second digit, and you will use this row for the negative 1.2 here, and they crossing at 0.1 1056. So then that should be the answer as 0.1 probability gonna be equal to 0.1056, or if I make it 3 digits, it should be 0.106, which is exactly the number that I found from the StatsCrunch. You see that? Okay, so that is a way by using Z table. Okay, let me combine with the PowerPoint, and I'm gonna move to the next page now. Okay, so in here, as I showed you before, they also show you firstly, you need to convert the information in the problem into the standard score or z score. So this was x value, which is 28. Now minus for the mean and divide by standard deviation, then you get negative 1.25 as I show you. Okay, so now look up for negative 1.25 on the normal table. You have negative 1.25 here, 0. And then the second decimal is 5 here. So the answer should be 0.1056. That should be the answer. Okay. Okay, so now going backward, finding x value given probability, sometimes we are interested in finding the value from the random variables associated with a given probability. So sometimes, actually, for example, sometimes if I have, here's normal curve, and if I have like mean is I don't know, I'm gonna say like 2, and standard deviation is 1, right, something like that. So then this will be 3, something like that. Okay. um, but the thing is, I have an area such as say um, here is, I don't know, maybe should be around 40%, right? And I'm saying, oh, what is value of x here gonna be? I'm looking for it. Okay, so um, how can I find it? Um, and that is, we have to use the backwards to finding the x value by given the probability. Okay, or the probability in here was 0. Sorry, 0.4, right? Okay, so how can we handle this? Uh, that's what we're gonna go to the next page. Okay, and now keep going with the seal. Um, we still have normal distribution with mean is 29.5, standard deviation is 1.5, 1.2, and what we do is suppose pups with length at 15 percentiles and below are unlikely to survive. What bird length would make it unlikely that the pup would survive? Oh, okay. So here is curve, right? So I have the mean was 29.5. I have standard deviation is 1.2. Okay, they say the length at 25 percentile are below are unlikely to survive. So let's say here is 15%, right? Of the area we gonna give you the probability in here is gonna be 0.15 and 0.15. Yeah. Um, that area is will unlikely to survive. So unlikely to survive, right? So then the if they say what but make it unlikely that pup would survive, that means what? Uh, that means we need to figure out what is this point, and then we're gonna have like probability of x less than this big X. Okay, less than or equal to. Okay, so how can we find this letter X here? Letter X here. Okay, so let's move to the next page. Okay, so here is a way to using StatsCrunch. Okay, firstly, here in the shaded area going to be equal 0.15, like I did explain to you guys, and the x value that's corresponding with the 15 percentile going to be equal to 28.3. So here 28.3 inches. Okay, so how can we find it? Okay, so let's go back to the StatsCrunch. Okay. Here's StatsCrunch. Now I still have mean is 29.5. I still have standard deviation is 1.2. But now I don't know what is this guy, but I know that the probability should be 0.15, right? Then I'm gonna click compute, and easily you will get the answer is 28.25628, right? So that is a way to find by background, which is the easiest way. And if you consider to use a calculator, TI-83 in here, let me show you also. Okay, here's my TI-83, right? TI-84 gonna be the same. So what you do is you again you will click on second, and now you're gonna click on the distribution here. Okay, so now instead of using the normal CDF, you now, because you are looking for the inverse way, the backward, right? So you want to take a look at the number 3 here. It have INV norm, which means inverse norm. So click on that, inverse norm. Okay, so for this inverse norm, you need to click. You need to put the number, with the percent first. So we is 0.15. Sorry, the probability first. Okay, 0.15, and now you comma, and then you put the mean. It was 29.5, right? 29.5. And then you comma and you put a standard deviation. It was 1.2, and then close parentheses and enter. So you see that you're gonna have 28.256. We round it to the first digit, is gonna be 28.3, or exactly exactly have the same answer as here, down here. So that is a way for using TI-83. So the formula is going to be inverse TI-83, going to be inverse norm, and then let's say the probability, and then comma, you're going to put mean and standard deviation. Okay, so that's for TI-83. Now let's move to the next page. Okay, this also show you the way I just did by TI-83. That's going to be for TI-84. Same thing, right? Using you push two distribution, and then option number 3, inverse norm. So yeah, good. So let's move to the next page. And now normal or inverse normal. It is known that the height of adult men follow a normal model. For each of following situation, decide if it is a normal or inverse normal problem. Okay, so a clothing store manager wonder what percent of her customer are taller than 6 feet. So because we are looking for the percent, right? What percent, right? That means it is normal, not inverse. Okay, so we are actually for looking for the probability also, right? Or we are just that. So that is normal. Okay, now what about the next one? Okay, a clothing store manager wants to cater to the tallest 20% of men and wants to know what heights we should accommodate. Okay, so for this problem, um, we are looking for what heights she should accommodate. Uh, so they given the percent given, right? Or they given the probability, all right? Or they given the area, but they are looking for the height, which mean they are looking for the x. And that mean what? That mean it should be inverse norm, right? Because we are not looking for the probability anymore. We looking for the height. We're looking for the x value. So it should be inverse norm, right? Okay, so 6.2 is done, and I'll go ahead and work on chapter 6 and see you in the class.